care of any they were locally. Yes.
Can you see my screen?
Yeah, now I can see your screen.
So let me show you. So I've collected this one. This is a relay,
Okay.
single module, single channel. I have error there before, but I've corrected the error.
You are getting an error.
So I've corrected it. I'm getting
Okay.
error, but I'm just getting the warning now, which I believe there is no problem. Let me show you the second one. So this, I decide this one,
Okay.
BMP
280.
2080.
Yeah.
So this is my cabling. So what I discover is like I'm having error, which I don't know where the error is coming from.
Okay. So I think it is showing some arrow, right? Indicating where exactly the error occurred in the layout design.
There is no error here.
Can you just show me that?
It should be, let me come to the front.
I can see it is
This
indicating in
error.
multiple areas, right? Multiple regions.
It's showing error here, so I don't know where the error is coming from.
Okay. It is showing an error over here. Okay, fine. So can you just show me the DRC output again? No outline found. Okay. No. From circuit diagram, it's fine. In the layout only, it is showing the DRC. Show me the DRC output once.
Okay, sir.
Board has malformed outline. Have you used the edge cut layers before?
Have I used what?
Edge cut layer.
No.
Okay. So you have any idea about why we use edge cuts layer?
That is why if you take my screen, I send any desk to you. You can take my screen and do that, sir. I
Okay.
send the
Okay.
invitation of any desk, so we can use any desk to do the demo for
Okay.
me.
Okay. I will open any desk.
Open your any desk. I've sent invite to you, so you take control of my system
Okay. Okay. Sure. I'm doing that.
so that I can learn from it.
So here I need to enter your IP address, right?
Just enter the number I sent to your
Okay.
any desk.
It is
1341017.
1341, then
Yes,
zero one
zero one
seven
seven
152.
152. Yes. I will accept you now.
Yeah, I think I have sent a request. I think you need to accept that.
I've accepted it, sir.
Okay. Let me check.
So you can go to my kite card.
But it is showing a cross mark over. I think I'm unable to. Your screen is visible, but I am not able
My
to.
screen, you can see my screen. Use your mouse to control things.
Yes. Actually, I'm trying to do that, but it is showing cross mark over the cursor. I will share my screen once you just verify.
You already have control of my screen. Hello, sir.
Yeah. So I'm just sharing the screen once. Once you just check because I don't have idea about this AnyDesk. See, I'm already in AnyDesk and I'm able to see your screen.
Oh yeah, control my screen. Yes. Go to my screen and control. Go to that any desk. No, 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 no.
Okay.
This is my screen. Go to my Kai card.
I'm unable to open that. See, it is
Yes.
showing a cross mark over the cursor.
If
See.
you can open it, let me stop my screen. Open it. Yes, click it. Click my Kai card. You're already on my screen.
Yeah, I'm already trying to do that, but I can't. It's not opening. See, it's showing a cross mark. Whenever I just put my cursor over the Kai card, it's showing a cross mark. See.
Go to my settings.
I need to go to settings, right? Yeah, I'm in
From
settings.
my tax bar. Okay, minimize. Minimize. Can you see my Kai card?
Yeah.
You're already on my. Continue. You already have the control.
No, I don't think so. Actually, I'm able to see the screen, but I'm not able to control it.
Okay, go to browser. Oh, click my browser. With your mouse, click my.
I'm doing that. No, maybe I think you need to enable some permission. I think so.
Oh yeah, click it. Click it. Let's click it before I enable. Click that.
Yeah, I'm clicking already. I'm clicking on it, but it is showing a cross
Okay,
mark.
let me enable. Okay, let me try something, sir.
Yeah, I'll send
Okay,
you the
control my
screen
device. Don't
sometimes for
worry.
your reference.
Yeah, my device. Oh yeah, go sir. You can control it now. Can you control my device now?
Give me a second. I'll check.
Click it now. I've enabled it.
Okay, I'll do one thing.
Reconnect. I've enabled.
I will reconnect. Okay, I will reconnect in the same with
You
same IP.
reconnect. I've enabled it.
Okay, then I think I need to reconnect maybe.
Indicating that you cannot open.
Now click it, sir. Hello, sir. Hello, sir.
Yeah, just 1 second.
Yeah, just 1 second.
Okay, now I'm just trying to click on KiCad. Let me check if it's opening or not.
It's opening. Oh yeah, go to it.
Yeah, I think now it's working, right?
Yes.
Okay, perfect. Okay, so actually here you have used one layer, right? This is what copper layer. Okay, so
Yes.
every PCB in layout designing, it must have something like an outline. Every PCB must have an outline. So within that outline, all components should be there. Basically, you have drawn an outline, but this is not considered as the outline. While DRC is, while DRC checking is going on, this particular box that you have drawn, the rectangular box that you have drawn, it is not considered as the outline.
Okay.
What do you think the reason could be?
You said?
So you have drawn on one outline, right, for the PCB, the rectangular
Yes,
box.
yes,
So while
yes.
DRC is being analyzed, this particular thing is not considered as the outline for the PCB.
Okay, okay, okay.
So I'm just asking, like, what do you think the reason could be? Why it is not considered as the outline of a PCB?
Because I didn't click the edge cut.
Yeah, perfect. Because right now you have selected the layer back copper. Okay, for drawing the dimensions of a PCB, it should be edge cuts. Okay, here you can find in the list, you can find edge cuts layer. Okay, front copper. Okay, yeah, edge dot
This is
cuts.
it.
So
Okay, okay, okay.
whenever you just assign the layer edge cuts, then only this particular the curve that you have drawn, the rectangular curve, that is considered as the uh, board outline. So, and one more important thing is, like, every PCB must have an
US.
edge dot cuts layer, because it is the only layer which defines the outline of a PCB. Hello.
846.
And I'm with you.
47.
Yeah, now you are audible. It is showing a network
Okay.
connection lost. Give me a second. uh, I'll try
Yeah,
to
I'm with you. I'm listening to
I'm
you.
clicking on retry.
Yeah, I'm with you.
While going, don't close the door, because if we close the door, our Wi-Fi is not coming. Yeah, I think I sent to another request.
I don't
I've
finish.
accepted it.
2000.
Okay.
Keep on now. Have you seen it? Peter, my name is Peter.
I've accepted it.
It is showing still connecting.
It's connected
Waiting
now.
for image. Yeah, now I got it. Give me a second. And again, same issue. Yeah, unable to
Okay,
open
restart.
apps. Can you do the same thing that you
Okay,
did
I'm coming.
earlier?
Okay, I'm coming. Oh yeah, go ahead, sir.
Yeah. Okay, fine. Now it's perfect.
1,000. Send me.
Good man.
Again, it's stuck. I don't know what's happening.
To your right side.
Again, I think it is taking some time, maybe, to load. Okay, it is showing something over here. Let me check. Board has malformed outline. No, it just found on edge dot cuts layer.
It's too big. Can I reduce it?
Yeah, just give me a second. Let me just perform the DRC once again. Yeah. See, now DRC is solved. So what happened earlier? Can you just what's your observation?
Alim, am jitin nan bege babu.
I did only small modification. I
The
haven't did
the the
anything
the
big.
the, the R2 lay
Alim,
on the cape on the wiring.
Right. See, already we discussed that during the previous session. Maybe in ECEDA we discussed certain rules where we discussed that these designators or silk screen layer should not overlap with the footprint. Okay. So
Okay,
always
sir.
remember the designators or whatever it could be any silk screen layer. It should never overlap with the footprint, the main footprint. Okay, and the copper layers.
Okay, sir.
If it overlap, yeah, if
Okay,
it
sir. I
overlaps, then it
understand, sir.
will
Now.
return a DRC error. So that is one of the issue I think you are facing right now. Okay, is that clear?
It's clear. For standard boy, if I want to print, should I need to put this R2 there? Or I should remove it.
Sorry, can you repeat?
R2 could I
Yeah,
make
you are
it?
asking me the question, should
Should
I
I
keep
remove it?
R2 or shall I remove the designator R2, right?
Yes. Yes.
See, actually that's your wish. So you if you want to keep the designator, you can keep, or else if you don't want, you can remove. But it is suggested that it would be better, at least if you want, you can reduce the size of the R2 designator, but at least keep some designator. Okay, because even that helps during the assembly also. Okay, keeping these labelings is one good thing. But as I can see, maybe if you want, you can reduce the text. I mean, size of the text if you want.
Okay, sir. Thank you. Then
Yeah. So
if you
today,
look
like
at this
from this
project,
thing, the two major issues that I identified is like the first one is for the outline, for the PCB outline, you have used the copper layer. Okay, never use front copper or back copper or any other layers. You must, for drawing the outline on, for making the dimensions of a PCB, you must use edge dot cuts layer only. And every PCB must have edge dot cuts layer. If you do not have edge dot cuts layer used in your layout design, then it is invalid. You must use edge dot cuts layer for defining the borders, the outlines, boundaries of a PCB. Okay, this is the first thing. And the second thing is like the designators or silk screen layer, it should not overlap with the main footprint or copper region.
okay, sir.
Yeah.
Then
So these are the two things.
second question
Yeah.
is a good thing. My track. Look at the size.
Yeah.
Is it professional? Because I realize that some people they use thicker one. They use like in a track use now. They width. They use one for the carry voltage because of the noise. What is your view on it, sir?
Okay. I didn't understand the complete question. So some people will use what?
The question is the track wideness.
Yeah.
Okay, assume like this. Let me do it, sir. 1 minute. So now what I'm trying to ask is just like if I come here now, my the width, the thickness of my track,
Okay.
is it need to be thick? Is it need to be thick? That is my question, sir.
Okay. So what should be the thickness of your copper tracks? That's your question, right?
Yes, That is my question.
Yeah,
For the
see,
grant, for the
I understood. I understood. So for this, already we discussed the track width formula. Using that formula only, we can determine the width of the track. So basically, what actually people do is like in professional designing for VCC, they usually put a little bit, or else for power supply related rails, they usually put a little bit wider track. And coming to the data or any other all other tracks, they usually put narrow only. Okay, if you want, you can increase the thickness, or else you can little bit widen the VCs or power related rails.
okay, in this situation, what is the shortcut? How can I increase it now without deleting it, sir?
Okay, so this is BMP 280 PCB, right?
Yes.
Okay, okay. So can you just open the data sheet once? Can you just check the current requirement once?
You have the access, sir. You still have the access to mine. Hello?
Yeah, yeah, I can hear you.
Okay, sir. I'm with you, sir.
Okay. Yeah. So right now you are using how much thickness? Can just let me know. Let me check. Okay. So I think right now you are using 0.5 mm, right? The thickness.
I'm using default.
You are using 1
I
mm.
use default. I know I use default. Yeah, I use default for
You are using
everything.
the
Yeah.
default one. Okay. 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 Fine.
Yes, for everything. So I want to increase it, for instance. How should I do that without deleting my
So
wire?
actually, let me tell you, actually in BMP 280 schematics, so as I can check, for power rails it is 0.3 mm. Okay, it is 0.3 mm, the standard track width. Okay, as per the documentation, it is 0.3 mm. But if you want, you can extend it all the way up to 0.5 mm. Okay, so this is for VCC and ground. For VCC and ground, track width can be from 0.3 mm to 0.5 mm. Okay, and coming to the other things like serial data or serial clock, you can put it something like 0.2 or 0.25 mm. Okay, 0.2, okay, you can go with 0.2. For VCC and ground, you can use 0.3 to 0.5 mm. For all other things, you can use 0.2 mm. Okay.
Thank you, sir.
Yeah.
So this is what I've done.
Okay, you're having a push button. Clearance violation. Yeah, this is very common DRC error. So
Okay, sir.
clearance violation means between two different things, two different objects that KiCad expects a minimum distance, minimum spacing, something like 0.5 mm, like that. Let me see where you got that. So yeah, here it is. So okay, I'm going to tools. I'm going to tools. Can you give me access to access control again? Okay.
I've given you. You are the one controlling it, sir.
Okay, but I am able to access these below options, but not able. Can you just check again? Okay, okay. Now I got it. Okay, now I got the permission. Okay, fine.
don't forget to write this data and this for paper. Hey, now well done. Ali, you get my starter number. You know, say on for your phone. Hey, let's go there. Go house again. Abu Maria, good afternoon. Abu Maria, the greeting. Good afternoon. See. Oh, man. They do, and I say, first way they mess for me. Are you young, Goma, my brother? Don't go there. But young, they worry me. Inbuilt,
It is actually taking long time. Okay, let me see.
Yes.
It is not updating so quickly.
Okay, maybe my internet. I'm not at home. Sorry.
Okay, no issue. Let me just check. Arey, what happened again?
The cow, when they won't use bury you, they don't burn us.
Your days are numbered.
They call me old man. You the old papa.
We beg for number.
Like that old woman where they serve that day.
They're begging me for number. The big guy. Yeah? Okay.
Clearance violation, clearance 0.2 mm, actual 0.15 mm. So this error happened at, see, clearance means what? There should be the minimum distance between two different objects. Okay, so what happened here, the minimum, see, it is showing with the arrow. Okay, keep that DRC box again. Inspect.
Sir?
Yeah, actually I'm trying to access, but it is not responding, I think.
Okay, let me assist, sir.
Yeah.
Where should I go, sir?
Yeah, go to inspect and again once click on run DRC. Okay. So can just yeah. So can just go with the something like the second one or click on PTH pad. Okay.
This is the error, sir. This place, sir.
Okay. So you have placed them manually or are they available directly in the default footprint?
It is directly, sir.
It is there directly available in the footprint. Okay. No. Nothing wrong in schematic. Schematic is okay, perfect. The only thing is like the clearance error in the layout design.
Let me assist you, sir.
What's going on?
Let me assist you, sir. 1 minute.
Yeah, sure. I'm doing nothing.
Let me
Actually.
assist.
Automatically, I think it's.
You can drop the mouse. Let me assist you, sir.
Sure.
You can release the mouse.
Yeah, I already released. Okay, thank you. Before that, let me save.
We can remove that, sir.
Let me just check again. It is showing that the current clearance is.
Sir, we can remove that state. We can remove this. We can remove this. Let's remove it, sir. Yeah. So is this pin that is giving us problems, sir? Or should we change the foot?
Yeah, okay. So here actually what happening is like, you know, between this ground and VCC, it's only 0.2 mm. It should be point 0.5 mm at least. So actually, I think so. By default, the footprints are designed, with the minimum spacing and clearance rule. But I just don't know why this particular footprint is not following the rule. See, actually here it is 0.2 mm only. It should be at least 0.5 mm. I think again if I run this again it will return. Let me check. Yeah,
Yes,
so you need to
sir.
change this footprint actually.
Thank
Yeah,
you, sir.
you need to change this footprint because this footprint is not having the not following the DRC rules. It is violating the DRC rules. You are not following the
Okay, sir.
clearance principle. It should be at least 0.5 mm between this ground VCC and all these pads. It should be at least 0.5 mm.
Okay, sir. I will try and change it, sir.
Yeah, you need to change the footprint. Yeah. Okay.
No error, sir.
Yeah.
So, but sir, like this one now, can I can I do something like this?
Something like.
Sir, can I do something like this?
Yeah. Once you just click on run DRC, save and run DRC. Zone ground on F copper and back copper priority 0. Thermal relief connection to. Wait a second.
Hello, sir.
Yeah, yeah, I'm just checking. Okay, this is fine.
Okay, is this stroke, sir?
Yeah, that particular stroke, I'm just checking that. So I think here you are having two strokes, right? So actually one
Yes,
stroke should be there, not two
yes,
strokes. Because
not to
if you are
stroke.
having multiple strokes, then KiCad may not be able to know which stroke to consider. So you
Okay,
can
sir.
do one thing. So every stroke will have something called priority. You can give the priority. Okay.
Okay, sir. How, sir?
So we can do one thing. Okay. So first what we
Okay,
need to
sir.
do is like we need to go to the zone properties. There we can assign the priority. Okay.
Okay, sir. How, sir?
Yeah. I think I lost access again. Yeah, again. Yeah, now it's responding. Okay, ground. So actually, you are having ground. This particular thing is connected to ground on both front copper and back copper. Do one thing. A second.
Hello, sir.
Yeah, I think I lost access. Wait a second. Hello.
Okay. Do you have access now?
Yeah.
Can I leave my board there without putting ground to it, sir?
You can live without putting a ground, but it is advisable to use a ground plane
Okay, sir. To fill it with a zone.
because using a ground plane is recommended. It will. We are having so many advantages of ground plane. Okay, you can do one thing. Is there any option to share this project with me so that I will just look into it at my free time?
Okay, I will do that, sir.
Yeah.
That. So lastly, sir, the question I want to ask, I have this project, is giving me, I want to, for instance, I have all the, I put all the sensors into different sheets. Are you with me, sir?
Yeah.
Can I have different 3D for them? Three different schematic for them, sir.
Can you add 3 different schematic projects?
This schematic, I have different schematic for this project, sir.
Okay.
Different sheets. This is one. I design it like this. I design this. I want to have different. I want to have different PCB for them. Is it possible, sir?
You want to add? Can you repeat the question?
I have different sheets, pages, something like this, sir.
Okay,
Hello?
you are asking me a question whether should I draw the schematics in the same page by differentiating or should I need
Yes.
to
Are you
do
seeing
the
my screen,
schematic in
sir?
separate page?
Yes. Are you seeing my screen?
Yeah, I'm seeing your screen. In this current page, they are like block of schematics.
Yes. I have four schematic. I have four like this. Different page. Can I have different PCB for them?
Okay. Yeah, you can have that. You can create a new PCB also for different things.
How, sir?
I'll do one thing. Okay. So I'll record a video. Okay. Because right now I'm little out. So I'll do one thing. I'll record a video how to create a PCB, different PCBs. Okay, you can go through that and follow the same instructions. I think I already had a video with me. I think so because maybe in some last
Thank
lecture
you,
I
sir.
explained that. So I'll share that video with you. So you can go through that and you can do the same thing. Okay.
Thank you, sir. Please help us share the this week video, your compilation of video. Share it with me. Thank you, sir,
Yeah,
so
yeah, sure,
much. I'm
definitely.
pleased to have you.
So as of now, so from today's session, the first thing is like educates layer. That's the one thing you missed, and second thing is designator. Okay,
Yes.
and the third thing is the clearance. So whenever if you add some random footprint, if it shows the error, mostly the default footprints they do not have any kind of DRC violation. Just if in case if you are manually creating a new footprint, then it may cause an error. If you are using the default footprint, then I request you, if it is again displaying the clearance error, then I request you try changing the footprint. Okay.
Okay, sir.
Yeah. And
Thank
between
you
the
so much, sir.
pads, it should be at least 0.5 mm. That is the clearance rule. Or else, alternatively, if you want to override this DRC rule, you can click on edit DRC rules and in that change the clearance rule from 0.5 mm to 0.2 mm. Then it will override the error.
Okay, sir. Thank you so much.
Yeah, sure. Welcome. And by the way, have you watched that videos, the two videos of OPAMP, operational amplifiers?
Yes, I'm going to be free today, sir. So please share all the videos with me so that I can watch it.
Yeah, yeah. Okay, sure. Okay, sure. Definitely.
Please share all the videos with me or YouTube link
Or
so that I
else,
can
if you
start
want, I
watching
will.
the.
Or else, if you want, I will explain about that OPAMs in a while.
Uh, Sorry, I'm in working class, so I have to go to office
Okay,
and
okay, fine.
treat the.
Yeah, please. Then okay. I think I have already posted the link to that video, so you can check in the same group, KaiCAD group. There you can find two videos. So actually, these operational amplifiers, it's like a small IC, very small chip. And the small chip can perform addition, subtraction, basic fundamental mathematical calculations to all the way up to differentiation and integration also. Okay.
Okay,
So
sir.
like sine wave, right? I'm sure that you know how sine wave looks like, sinusoidal wave.
Yes, yes, yes.
So do you know what is the integration of the sine wave?
No, but explain. I will understand it, sir.
Yeah. So integration of sin x is minus cos x. So if you give the sinusoidal wave, at the output you need to receive the minus, the negative, I mean the same cosine wave, which is nothing but the integration of the sine wave, but it is in inverted format, 180 degrees turn. So this small IC can do integrations also, just a small IC, operational amplifier. So it is actually came during World Wars. So during World War II, there is one scientist called Ragazzini. So he is the first person to make the analog computers during that time during World Wars. So he worked a lot on operational amplifiers, and all this happened in 1940s. Okay, so finally today we are using op-amps which is having so much of which can perform so many cool things. So if you don't mind, can you just come back to Google Meet? I will show you one such example.
Go ahead, sir. Let me see, sir.
Yeah.
You can share your screen in Google. You can use my screen, sir. You can
Okay,
use
okay.
my browser.
Acha, got it. Actually, I have shared that URL in the WhatsApp. Okay, or else I will try to browse the URL. Cat. So the link is Okay, I'll post the link in the chat box because I do not have, I think I'm unable to paste the URL. So I'll post the URL in the chat box. Am I audible? Am I audible?
Hello, sir. Can you hear me?
Yeah. It is showing connecting. Once again, can just accept the request. Okay. And the permission also.
The 14, I want to have for me.
Eh,
I suppose to tell you
Okay.
for 3.
Thank you.